Depth of field is an effect which is sometimes featured in 3D video games. For those who are not familiar with it, it is a concept which comes from photography, which has to do with the focal length of a physical lens. It's the effect where you can focus a camera on something that is some distance away from you, and things that are way in the background or way close to you in the foreground will be blurred out. And you may wish to apply it in a video game. Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's talk about depth of field in GameMaker. So, depth of field in and of itself isn't a complicated subject in the grand scheme of 3D games in GameMaker. There's a couple of different parts to it though, so it's not exactly what one might call entry-level material, but once you understand how things like blur shaders and multiple render targets and texture samplers and a little bit about post-processing effects, it's not too hard to combine all those things into a depth of field effect. So I have a very basic example up here right now. You can see that things that are far away from me are increasingly blurry in this example, whereas things that are right in front of me, right in front of the camera, specifically whatever's in the middle of the screen, is much sharper and more in focus. So let's get started. First, my actual demo project for this video is going to be basic 3D scene. I did go ahead and clean up some of the bits of code that have been hanging around in this 3D demo scene for a while without actually being used. So the sampled project should be a little bit slimmer than it was the last time we spoke about 3D in GameMaker. So where do I want to start? Like I said, there's a couple of different pieces to this. There is, we're going to have to encode the depth of a scene to a texture. We're going to have to take the main image that we're drawing and blur it. I guess I'll start by encoding the depth of the scene to a texture because that's pretty easy. I'm going to be making use of a 32-bit float texture for this. If you want to, you can use the old encoding depth as a color trick and use a regular RGBA8 surface for this. So let me go into the camera's create event and let me initialize surf depth is going to be surface create. The width can be window get width. The height can be window get height.
Hey.
And as I said, the format can be surface R32 float for a 32-bit floating point surface. I'm going to be making use of multiple render targets in the main 3D stuff shader to make this work. And that is as easy as surface set target extended. The index is going to be 1. The surface ID is going to be, surf depth. As always, when you're setting a surface target, it's a good idea to make sure the surface actually exists before using it. And if it doesn't, to recreate it. But I would like to move through this quickly, so since this is just a little demo, I kind of expect you to know that already. Going into the basic 3D stuff shader, I'm going to want to take and you can use the glfrag Z divided by glfrag W scale depth for this if you want, but I think for things like depth of field or for things like distance fog, it's just as easy to just use linear depth between the camera and the fragment that you're rendering. So I can say varying float v underscore depth, and I can assign depth to simply the view space value of geomatrix's matrix world view times the input position, and I just want the z coordinate of that. So convert the vertex position into view space, and then the z coordinate of the view space is going to be distance into the screen, distance from the camera. So that's good enough for me. We're also going to have to varying float v underscore depth in the fragment shader to actually make use of this. And then to actually encode this as a color to the texture, I will need to say glfrag data index 0, because we are now using multiple render targets. That can be the diffuse color. gl underscore frag data index 1 is going to be a vector 4 composed of v underscore depth, 0, green and blue, and I'll assign 1 for the alpha, even though it's not going to be written, just to avoid weird blending shenanigans. So this is going to render depth to our texture. If you want to see what that looks like to make sure that it looks correct, let's draw the surface, draw a surface, scaled, so surf underscore depth, can draw it in the corner. X scale can be, let's say, 0.25, 0.25. And that should show a black image with red wherever something's being rendered. This will not, like, if you are encoding depth as a color, then you would obviously see more with the different bands of color in the corner over there. But since we're just encoding the actual depth as a float, which isn't necessarily a constraint between 0 and 1, then this surface is just going to be drawn as like a red, a pure red, wherever something exists. So that is our depth texture. And I'll commit the change of rendering depth to a surface. So the next thing I'm going to want to do is I'm going to want to take what's on the application surface and blur it. So we're going to have the application surface itself, which is what's being drawn in the 3D scene without a blur. And then we're going to have a blurred version of the application surface, which is going to be the out of focus version of the image. And there are plenty of different ways that you can blur an image in shaders. I've talked about different like box blurs in shaders before. There are radial blurs, which are pretty similar, which produce a pretty similar result, but are maybe a little more efficient, can be done in one pass. Kawase blur is another two-pass blur shader. I believe in most like AAA games that use depth of field effects, bokeh blur is what is commonly used. Bokeh is another effect which simulates how light interacts with a physical lens, how light will be in focus or out of focus. Brighter parts of the image will be blurred more than darker parts of the image. I have not made a video on bokeh before. I probably will at some point because it sounds cool, but how exactly you blur the image for this isn't of utmost importance, since you can pretty easily just swap in or out any other type of blur you want. I'm just going to use a two-pass Gaussian blur. Like I mentioned, I've inserted a horizontal and a vertical blur shader into this project. So let me just initialize two surfaces. I'm gonna say surf blur horizontal, and then we're gonna have surf blur vertical. Really, surf, that's gonna be the final blur surface. And then in post-draw, I'm actually going to do that. I feel like people are gonna get a little upset about this, but again, since I don't want to spend a great deal of time dwelling on how to blur an image in this video, I'm just going to copy and paste this from my sample project. So this is a pretty bog standard how to blur the application surface in two passes. If you want to actually see that blurred image, we can just we can draw the blurred surface to the screen instead of the the regular image. That's depth. I wanted this other surface. We can draw the blurred image to the screen instead of the regular surface. All right, that's blurry. That'll do for out of focus for today. Again, you can swap in or out whatever other blurring technique you want. Should I like draw both of these to the screen? Nah. I don't want to have those taking up too much space on the screen. So that's the easy part. Let me go commit these changes as well. Now we need to actually figure out how to combine the in focus and the out of focus and the depth texture. We need to figure out how to combine those three inputs in the shader to create something that resembles a depth of field effect. So I'm going to create myself a shader. I'm going to call this shd_dof because depth of field is just way too much to type out every single time. Let's see. I think I can just maximize this post-draw event now, where we're actually drawing everything to the screen, because that's the the only GameMaker event I'm actually going to be really concerned with for the rest of this video. I am going to this is all initial setup, right? And we can just collapse that so that we don't have to see it and be distracted by it, right? I'm going to want to, when we draw the application surface shader, set shd underscore depth of field, dof, when we're done, shader reset. Somewhere in the middle of all this, we're going to draw a surface. I don't think I actually have to stretch it to fill the screen, because I think right now it just is the size of the screen. The application surface, x, y is 0. So let's talk about the actual depth of field shader, shall we? So we don't care about the vertex shader, because this is just a pass-through vertex shader. We don't have to do anything exciting here. In the fragment shader, we're going to need to consider a few inputs. There's the main image, obviously, the in-focus texture, which is going to be our application surface. That's gm underscore base texture. GameMaker sets that up for us. There's going to be 2 additional samplers. I can say uniform sampler 2D, and I'm going to call them samp depth and uniform sampler 2D samp blur. And those are going to be the 2 additional surfaces that we're working with, our depth texture and our blurred out of focus texture. Additionally, and I'm not going to address these immediately, but we may want uniform float u near, uniform float u underscore far, uniform float u underscore focus. These 3 floating point numbers are going to be the near distance. Things in front of the near distance are going to be out of focus and blurry. Things behind the far distance are also going to be out of focus and blurry. And we're also going to have a focal distance, which is going to control the like the curve of the blur effect a little bit. So these are going to be our inputs into the depth of field shader. Let me pop on back over to the post draw event. I'm going to set up the 3 uniforms and I think the samplers first. So texture set stage. The sampler ID can be shader get sampler index. The shader is going to be shd underscore dof. The name is going to be samp depth, and the actual texture is going to be surface get texture surf underscore depth. We're also going to want to do basically the same for the blur texture, the blur surface, the blurred surface, and shader set uniform float, shader get uniform from the same depth of field shader. U near, I think in my demo project I made this just like 100, so, or at least at the very least we'll start with that. We'll play around with it more later. There's going to be u underscore far, and I think I also made u underscore focus default to like 500 or so, and that'll be we'll worry about that a little later. So we're setting up the samplers, we're setting up the other uniforms. Let's go back to the fragment shader. So first I'm going to, let me sample from all 3 of the textures. So we have vec4 color main is going to be texture to 2D, gm underscore base texture. So that's going to be our main color. We're just going to sample that from the varying texture coordinate as we ordinarily would. Vec4 color underscore blur is going to be sampling from the blur texture. And vec4 color, actually no, I'll call it depth value, is going to be texture 2D from samp depth. And since this is a 32-bit float, since this is a single channel 32-bit float surface, we don't really care about anything besides the first component of the vector 4 that's going to be returned by this texture 2D lookup. So we can just say float depth value is going to equal this texture 2D samp depth texture coordinate dot red. So before we do any weird like smooth step math or anything like that, let's just first do a super rudimentary, like just to see that this is working at all. If depth value is greater than u underscore near, and if depth value is less than u underscore far, then gl underscore frag color is going to equal color main, and like you could say else gl underscore frag color equals color blur, but I want it to be really adamant if this is going to be drawing anything or not first. So before I even do that, all right, so we now see that our middle distance, things that are farther than 100 units in world space away from the camera, are drawn. Things that are beyond 500 or whatever I made the far distance are not drawn. This is basically the same effect as setting the near and far clipping planes in the projection matrix to those values. This is obviously not exactly supposed to be the same as the clipping plane, but like I said, I just wanted it really adamant that something was happening, that something was that some decision was happening in the shader based on depth. And now I'm going to comment out that else statement. And now things that are things that are closer than that middle distance are going to be blurry. If I were to stand right next to the pirate ship, it would be fairly obvious. That tree right in front of me is in focus. The trees that are farther away from me are out of focus. When I move backwards and forwards, you can see that there's a bit of a hard cutoff. All right. It's kind of working. It doesn't look great, but once again, kind of working. Guess I'll commit this change too. And we'll emphasize that it kind of works. All right, so let's make this smoother. So you can twiddle around with numbers. You can twiddle around with different interpolation, different methods of interpolation to smooth this out a little bit. The common way that you'll see of doing this is going to involve the smooth step function. I don't actually remember if I've talked about the smooth step function in a shader video before. So smooth step is kind of like lerp in that it will give you a transition between two values, but unlike lerp, instead of a linear transition, instead of a linear interpolation between two values, smooth step will give you what is known as a sigmoid curve. Sigmoid curves are basically S-shaped curves. There's a couple of them. I believe the one that smooth step uses is specifically a Hermite curve. If you've ever played around with easing curves, you've probably seen something like it before. I'll probably put a link to some literature where you can read more about it in the video description. But anyway, the smooth step function is going to take a couple of inputs. The first two are going to be the left and right edge. And the third argument to the smooth step function is going to be some value that is going to be in the middle of those first two arguments. And the function will return a value that is interpolated between 0 and 1 based on that sigmoid curve between the, as they are known, between the left and the right edges. And this is a very useful function. You can use it to do smooth transitions between all kinds of things. If you ever think the lerp function is a bit of a too abrupt transition, then you can play around with something like the smooth step function instead. The way that I'm going to make use of this is that instead of doing that if else with the depth value, I'm going to say float blur amount is going to be equal to smooth step with the left and the right edges being u underscore near, u underscore far. And what do we want for our third value? We can try just making this depth value itself. And then for gl underscore frag color, remember smooth step returns a value between 1 and 0, so we can then use that blur amount value to nice and neatly interpolate between in GLSL that's going to be the mix function between color main and color blur based on the blur amount. If this is what you're going for, this is fine. This will not blur things that are too close to you, but it will make things that are farther away from you progressively blurry. So anything that is, in this case, anything that is nearer to you, then the near distance is going to be perfectly sharp, perfectly in focused. And then as we transition between the near and the far distance, then it is going to get progressively blurrier. That is a valid way to do a, if you don't care about having things that are too close to your face being blurry. But if you want the full effect of objects that are closer than the near distance being blurred, and then like the same way that things that are far from you are blurry, then we can instead take the absolute value of no, not there. We can take the absolute value of the depth value minus the u underscore focus, and if I set up the if I set up the uniforms correctly, things that are close to us are going to be blurry. Things that are in the middle distance are going to be in focus. That ship is so big that like some parts of it are blurry and some parts of it are in focus at all times. Like that tree, those trees right in front of me are now in focus, but things that are closer or farther away from them are not. This is a very shallow depth of field because there's not a lot of space where things are actually perfectly in focus. A lot of it's like within that transition zone. Again, you can play around with the focus values. You can decide what looks good to you. If you want, you can even like build in a somewhat interactive bit of code, so you can say like use the you can use the mouse wheel to scroll the focus value so that you can decide what looks good. I should probably draw that value on the screen so that we can see what we're looking at. What happens when we scroll in, it gets really blurry. When we scroll out, it should get a little bit sharper. At least, yeah, the focus distance is actually, that's not bad. That probably would have been a better default value than whatever I typed in the first time. So if you want to do depth of field, play around with those, see what looks good to you. Another thing you can do, and this I believe is also fairly common in games that use depth of field, is to, instead of having a fixed focus distance, you can have the focus distance be based on whatever is right in front of you in the scene. So in that in the example I had at the beginning of the video, if you looked at something that was close by, it would be in focus, but if you looked at something that was farther away, it would the game would try to focus on something that's farther away. So based on like whatever is either under the mouse cursor, you can pass the mouse cursor's position on the screen as a uniform to the shader, or you can if you're using a first-person game, you can just go with whatever's in the middle of the screen. So how do I want to do this? Float depth under crosshairs is going to be sampling from the depth texture at coordinates exactly vec2 of 0.5. So exactly in the middle of the screen. And then we can use that depth under crosshairs value as our focus distance. It may be a good idea to clamp this this value between some like nominally small number, let's say between 10 and like 1,000 or so. Just because it would be pretty weird if we tried to focus on something that was like way the heck off in the distance, like a mountain or something in the background. And this will allow us to either look at something that's close by and focus on it. Like if I look at this tree that's right in front of me, it's going to be in focus. If I look at the pirate ship, the pirate ship is going to be in focus. It's still close enough that that first tree is going to be in focus. If I look at, I really should draw like, hang on. Let's draw, actually, let's make that an open circle. Let's draw a little circle in the center of the screen to serve as a crosshair. All right, much better. So I'm gonna put my crosshairs on that tree over there. The tree next to me is having a bit of a hard time focusing. If I focus on a tree that's really far away, then the tree that's next to me is really gonna have a hard time focusing. If I look at the pirate ship, it comes back into focus. And we have a rudimentary depth of field effect. Okay. So I think I'm gonna call it there. Again, I would like to reiterate that you can play around with these numbers and these transitions and these cutoffs in as many ways that you want. You don't have to have things that are closer than the near distance be out of focus if you don't want to. You can have a fixed focal length if you want to, or you can have a dynamic focal length like this if you want to. Whatever you think looks good. I would probably encourage you to use a better blur shader than the one I'm using, but that might be a story for another day. I'm going to end it off here. My name is Michael. I like Wizards and Dragons and making games. If you want the code for this, look for the GitHub repository down in the video description. This video took several attempts to record, and I think I finally got a take that I actually like, so I hope this is something that comes out to be useful to you. If so, I try to post about 2 game dev videos a week, one tutorial like this, and one let's make a game. Currently a 3D Zelda-like wizard game, so if anything like that appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. Otherwise, I hope you all enjoyed that, and I will see you all later. Special thanks to Zenjamin, Vitro V, Squarecrow, Syndra Larson, Manta Ray, GameMaker, Edward Holt, and DJ Gibbles for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.